1 of chapter 10. Let's have some revision first. First of all, there are two formula you learned last time. One is sine formula and other one is cosine formula. So what situation you will apply sine formula or cosine formula? They can apply the first one in any triangle. And then for how can I apply the sine formula is if I know the angle B and the length B. Okay, so angle B I know it and the size of B I know it. Then I can find the others by sine formula. Okay, so for second one, for cosine formula, it should apply in two different formats. The first one is SAS, so which is we apply it to find the length. So what does this mean is that SAS is the size here and the angles here and the size of A. Then you can find the length of B. And the second format should be SSS format. Okay, so if I know the length of three sides, okay, the first one, second one, and third one, or then I can find the angles. Okay, so and then if the triangle is a right angle triangle, then we can apply a simple sine, cosine, and tangent function to find the length or the angles. Okay, so and then for the second concept today is what's the meaning of angle of elevation and depression? Okay, so we learn it in secondary 3. So first of all, we have a horizontal line, and the angle you look above the horizontal line is we call angle of elevation, and the angle below the horizontal line is we call it angle of depression. And once you know that the horizontal line is parallel, so that means the angle of depression, which is equal to the angle of elevation, and the theta must be acute angles. Otherwise, it will become an acute angle with another direction. For example, if you have a horizontal line, and if the angle is more than 90 degrees, okay, if this is an angle of elevation, then you will change the right direction to theta 1 here. Okay, so now let's jump to the example for the first one. So how can I solve this problem? First of all, you need to figure out whether it is a right angle triangle or any triangle. So and the second one, you need to think about it. You need to apply the sine formula or the cosine formula, or you just when you encounter a right angle triangle, then you can apply this trigonometric function easily. So the first one, find the angle of elevation of B from R. So that means our target is how to find theta. And first of all, we consider the triangle TBR, right? And we have a SSS format. So I can apply the cosine formula to find the first step, this angle. So this is a part 1. After that, you can use 90 degrees to minus the part 1. So it's the second part. Then you can get the answer. Okay? So for second question, in the figure, a balloon is at C here, and they lie on the same horizontal ground, and give the information above which is shown in the graph. So the keyword is find the distance between B and C. So we need to find this one. Okay, BC. So first of all, I know this angle according to the angles on straight line, and we can consider the triangle ABC. So we can notice this is a SAS format. So I can find the question mark BC by SAS format and by cosine formula. So it's not difficult for question number 2. Okay, and then for question number 3, so for the first part, find the distance between B and C. So that means we need to find BC, this length. So let's consider the triangle ABC. So let's see any SAS format or a sine formula, the corresponding angles and sine format. So first of all, I know this angle, the first part, because we can have a exterior angles of triangle. Okay. And for second part, if I know this angle ACB, then I can have a pair of angles and corresponding sides. So this is easy because we have a parallel line. So it's 25 degrees minus 12 degrees. Okay, this is the second part. So finally, we can apply the side formula to find BC. So therefore, I can explain to you that for the first part, this is the first part by exterior angles of triangle. And for second part, we find the angle of ACB. And for the third part, you can find BC, this third part, by applying the side formula. Okay, so you can find BC. And the second part is find the height of building CD. So let's consider what triangle we have. For find CD here. So let's consider the triangle CBD, right? Oh, it is a right angle triangle. Then we can apply the trigonometric function directly, okay, because we have found BC before, and the angle of CBD is 25 degrees, so it is easy to get the length of CD, okay? So it's right angle triangle. And the last example is, okay, as the graph showing is in the data, in the figures, so the first part is find the distance between A and P. So A and P is here. So for the triangle APP, okay, we can get the first part is this angle, angle A, and we have a pair of it, pair of angle and the side. Then we can find our targets by applying the side formula. So this is the first part to find the angle PAQ, and the second part we find AP by side formula. Okay, so for part B, find the height of AB. Okay, find the height of AB. So I just considered one triangle, which is APB, which is a right angle triangle. Okay, so that means I find AP in part A, so it's easy to get the answer of AB. So APB. Oh, sorry, I make reverse of the point APB. So I find AP before, and the angle of APB is 31 degrees, and then you can get the length of AP easily. Okay, so that's the end of worksheet 1.